This video serves as a follow-up to video 3, solving with the square roots. The first and one of the most important thing is that we always take the square root of both sides only when the x squared is by itself. So if I have x squared equals something, that is when you can take the square root of both sides. Not when you are still adding, or if you are multiplying or dividing with your x squared. So to that end, in a problem like number 1, I would have to first get the 7 out of here by subtracting 7 on both sides. X squared equals 1. Now that x squared is by itself is when I can take the square root of both sides. Pay close attention to the directions. All answers should be in simplest radical form, no decimals. That means simplify your square roots. But if it's a perfect square, we don't have to worry about it. 1 is a perfect square. X squared, square root of that is x. And that equals, when I am square rooting both sides, there are 2 possible answers because there are 2 numbers that multiply to 1 when I multiply by itself. 1 or negative 1, because 1 times 1 is 1, negative 1 times negative 1 is 1. 2 answers when solving. And again, remember back to Unit 8 when we talked about largest exponent is the maximum number of solutions. This could have 2 solutions, and in fact this algebraic equation does. The only difference in a problem like number 2 would be I have to divide on both sides to get rid of the 5. So this goes back to our Unit 1. X squared equals 20. And now when I square root both sides, the square root of x squared is x, but 20 is not a perfect square. That's when we have to do our simplify our square roots. 2 times 10, 2 is prime. 2 times 5, I have square root of 2 times 2 times 5. That's 20. 2 times 2 is 4. Square root of 4 is 2, so that comes out in front. 5 stays in. Square root of 20 becomes 2 square roots of 5. So my answer is not 2 square roots of 5, but positive or negative 2 square roots of 5. You can write it with the word or in between your positive and negative, or you could write it as plus or minus. But when you're solving, that's 2 answers. If you only give me 1, you're not going to get full credit. Real quick, if it's 1/3 in front, multiply, so you have a fraction, multiply both sides by the reciprocal. Your 3's, 1's cancel, that leaves your x squared equals 36. X squared is by itself, so square root that. 36 is a perfect square. X is plus or minus 6. There's my 3 answers to these 3 problems. All of those are very similar. Go ahead, press pause, and try number 4, please. So I know it's going to be x equals plus or minus, but I get square root of 24. Simplify the square root. 2 times 2 is 4. Square root of 4 is 2, so the 2 comes out. There's your pairs that are left over. 2 is outside. Square root of 6, and we're done. Here's a special case, so let's go ahead and take a look at what happens when we solve this one. If I subtract 54 from both sides, I wind up with 4x squared equals negative 44. Divide both sides by 4, I get x squared equals negative 11. Square root both sides, and here's our issue. Am I allowed to have a negative inside a square root? You're right, I'm not. Because there's no number I can multiply by itself and wind up with a negative. My number is either positive, and positive times positive is positive, or my number is negative, but a negative times a negative is also a positive. When this happens and we cannot do it, that's when we get a no solution as our final answer. There is no algebraic solution to this expression, this equation. So that's just showing you no solution, but also shows you you might have two steps. I want everybody to go ahead and pause and try numbers 5 and 6, please. So first, in solving for x squared, we should get x squared equals 12. Multiply both sides by our reciprocal here. Make sure you're using your calculator accurately. And here we get x squared equals 48. Now is when we can square root both sides. I always check if it's a perfect square first. I know a lot of the perfect squares. You might not. So put it in your calculator. If you get a decimal, that means you have to look to simplify this. In this case, it does simplify. I know it's going to be x equals plus or minus when I square root both sides. This becomes 4 times 3, square root of 4 is 2, square roots of 3. And in number 6, I look to do the same thing. X is going to equal plus or minus square root of 48. Well, 48 is not a perfect square. I get a decimal, so then I look to factor tree. And again, if you can factor tree it in your head, great. That's something I doubt you can. If you can talk me through it, then sure, let's do that. But otherwise, write it out. I look at this as that's 4 times 12. Oh, I see a shortcut. Because 12 is 4 times 3. I can stop simplifying here. I don't need all of my 2's. As soon as I see I have a pair, 4 times 4 is 16. Square root of 16 is 4. That 4 comes out in front. I get plus or minus 4 square roots of 3. So, press pause again and try 7, 8, 9, and 10. I am not going to go through all of these answers. I will, in about 10 seconds, show all of the answers with my work. But I want you to try it first. Okay, so at this point you see all of my work down to our x squareds. So we would be square rooting both sides for all 4 of these equations. And let me clarify something here. Earlier I talked about if you have that negative inside, we're going to say that we have no solution, and that's still true. But let me clarify something. We actually could get a solution here. And in Algebra 2, you guys are going to learn how I can solve this. We use what we call an imaginary number. And that imaginary number, and I'll just write this in a little light gray because it's not important for our Algebra 1 class, is called I. And it represents the square root of -1. Why we have it, why we use it, I'll leave till your Algebra 2 class, but understand that that's technically going to give us our mathematical solution here. But that's not a real number, it's an imaginary number. So what we will also, or often say, is that there are no real solutions when we square root a negative number. In number 8, we get x equals 0, not plus or minus 0. 0 doesn't have a sign. It's not positive or negative. It's just 0. So this goes back to Unit 8. We're going to have a maximum of 2 solutions here. We don't have 2. We have 1. But we don't have more than 2. We have 1 solution. No real solutions here. Maximum of 2 solutions. Number 9 is also no real solutions. The real is important there. And for number 10, we get plus or minus 2 square root 2. Last part of today, let's go ahead and practice our evaluating expressions and simplifying square root. So go ahead and do this whole section, unpause, and check your work. So I'll start by reassuring you or making sure that you really understand the importance of the parentheses here. That -2 for b squared has to be in parentheses, the negative inside parentheses, the exponent out. Make sure it's all typed in accurately. Number 2, we should get 49. Double check what you have in your calculator if you didn't. For number 3, again, it is incredibly important that we have our calculator set up right. Parentheses around the entire numerator. Your calculator will follow the order of operations. If you tell it to do 1 plus square root 10 divided by 2, it will divide square root of 10 by 2 first. because that's first in the order of operations. But if you put parentheses around the 1 plus square root 10, it will do that first, because that is the first step in the order of operations. It is imperative, it is necessary, mandatory that you put the numerator in parentheses here. And there are two answers here because there are two questions, plus or minus. And for number 4, we should get 1.02 or negative 2.52. And when we simplify down to our primes, 2 times 2 times 2 times 3 is 24. 5 times 5 times 5 is 125. Pair of 2's, 2 times 2 is 4. Square root of 4 is 2. Those don't pair up. So 2 square root 6. And 5 times 5 is 25. Square root of that is 5. A 5 is left over. 5 square roots of 5.